Hey guys, so I'm gonna go over the stats and regression uh review sheet and talk about that. And while I'm working through that, I'll basically toggle back and forth between Desmos and the document here just so we can chat through it. So I'm not gonna be able to write, unfortunately, because I wanted Desmos pulled up. And the only way to do that is the screencast. So just a reminder that when you start, so I'm on, this is a sheet I'm working on, right? And so far what I've done is I've put all my data into Desmos. I've got 16 elements, and I double checked over here and I counted and made sure that I had 16 pieces of data. So when it's asking to do a box and whisker plot, and some basic calculations, I'm just going to go through and remind you how to find those and make sure that you can build your box and whisker plot. So the first thing that we want to find is our mean. So again, you have two options here when you're using Desmos. One is just type it. I think that's the easiest option at this point because you guys know what you're looking for. The other option, to remind you, is to click this, click functions, click stats, and then click mean. And then anything else you might want in there: min, max, median, quartiles, all that good stuff, standard deviation. So mean is the first one. I'm going to shrink this down. The other one is median. The one thing you won't be able to find, remember, is mode. You are going to have to use your eyes over here to kind of look at this. So I'm looking at my data points, and I've got 1, 2, 295s, 265s. Those might be the two modes. I don't see anything else that doubles up. Oh, 285s. 285s, 295s, 265s. Yeah, that looks like it. So all of those would be part of our mode. Remember, to get range or interquartile range, you need some other things. So you need your min, which is your smallest value, your max. To get your range right, you can actually tell Desmos min of, sorry, max of A. Callie, no. Minus min of A. Shh, Callie. And then, lost my train of thought. Oh, and then you've got your quartiles, right? So you can go through quartile of A, comma, 1, quartile of A, comma, 3, right? Those are your Q1 and Q3s. And then to get your subtraction right, you can either use like a yellow calculator to subtract, or you can actually just tell Desmos, I want to do quartile A3 minus quartile A, comma, 1. So mean, median, min, max, range, Q1, Q3, interquartile range. Those are the key things that you'll need to find in this. From there, the main things that you need to remember is that if it's normal distribution or symmetric, that the best option for describing the data as a center is your mean, and the best way to describe how consistent your data is your standard deviation, which I forgot to type in over here. So standard deviation, remember, just hit standard deviation A, right? And so there's all my information. Callie, leave it. Come here. Hey. Hey. Sorry, I had to pause that. Callie wants to go play with the neighbor's dog, but she can't go play with the neighbor's dog, right? It's okay. So from there, you can just go through and answer your questions. Remember, on your pieces here, right? This is your min, this is your max, this is your median, this is your Q1, this is your Q3. The key things to remember are that each part is a quartile, which means that it makes up 25% of the data. So this piece is 25%, this piece is 25%, this piece is 25%, and this piece is 25%. And same thing with B, right? Every box, every individual box and every individual whisker is 25% of your data. On this one, he talked about what the shape is. So like this one we know is skewed left because the tail of it goes to the left, and therefore we should use the median, and we should use, as far as our options to compare how consistent the data, the interquartile range is our best option for when it's skewed. Whereas when the data is symmetric, like in part B here on 3B, nice and symmetric, we want to use the mean and standard deviation to describe how consistent the data is. Okay, and then the next part of this is talking about going through and looking at your linear regressions, writing linear functions for your data. So what type of correlation exists on this one? We can clearly see that this is a positive correlation, and because it's so clear to us, I would say a strong positive correlation. Now we wouldn't know that 100% until we got to put in the coordinates and look at the R value, which I'm going to talk about in number 7. But also when I'm looking at this, since I say it's positive, as the number of hours studying increase, the scores of the students increase. So all right, let's talk about one of these. I'm just going to do one and let you do the others as a good example to go through. So I'm going to do number 7 here. All right, so I'm going to start by adding a table in here where I can put my data. So remember, you can't do that over here because there's no function in there yet. That will give you a table if you already have a function in there. But if I want to get a table and put information in there, I'm going to go with this one. So let me drag this over so I can see it while I'm typing. So there's 2 ways. You'll notice that in the problem it says let x equal 0 for 1940. So one thing I can do is do 0, and then 1950 will be 10 years later, and then 1960 will be 20 years later, and then 1970 will be 30. And this is how we did it in class when we did it. But I do want to show you that I can also do this without changing those values, because some of you guys said you preferred to leave the dates as they were, and that is totally fine. It will work just the same, I assure you. So this is the way that it instructs to do it. So I've got my data in there. So remember, to get this to run a regression for me, give me a y equals mx plus b function. I've got to go down here and I've got to say y1, because remember the table says y1 is approximately, so I go to my table, ABC, approximately mx1 plus b. And so there's my regression. As I'm looking at this, you see how that's a negative 0.99. So as far as the R value means, remember the R value tells you how strong a correlation you have. So this is very strong, but it's very strong negatively, right? When it's close to -1, it's a strong negative correlation. When it's close to +1, it's a strong positive correlation. And when it's close to 0, it's got no correlation. So I've got that as my y equals mx plus b. I would like to see my data. So I'm going to zoom out or change my window, either one. The good thing about using the numbers the years since, I know that I don't need a ton of x's to see it. So I can already see 2 points. So there we go. That's a pretty good clean, right? That's almost, I mean, that's why it's so strong. As you can see, it's going through every single point on there. So it's really good. Okay, so let's look at some of the other questions that came along with this problem. This problem also asks, so we talked about our equation. So our equation would be y equals negative 0.06 plus 7.6. The R value we said was negative 0.995, which is a really strong negative correlation. Find and predict the number of people in millions walking to work in 2010. So 2010, that means that I want to basically have Desmos give me a table for this function. So remember, when we do that, we go down here and we put in the function we just said. So there's the function. And then I have Desmos spit out a table. So when I'm doing this, I'm thinking, okay, 1940 is when I started looking at this data. How many years since 1940 would 2010 be? Well, I already know 1990 is 50 years. 2000 would be 60. 2010 would be 70. So I'm going to put 70 in my X. And it looks like 3.4 million. I'm hoping that's not true. God, I hope we walk more to work than we used to. Um, but yeah, okay. So there's that. And then in what year was the number of walkers equal to 4.9 million? This is the one where since the walkers is Y, and I can't help but think of Walking Dead when I hear walkers. But since the number is Y, I'm just going to tell Desmos I want Y to be equal to 4.9. And then I click my intersection and I get 45 years after 1940. So 45 years after 1940 would mean that that'd be 1985. When I would have 4.9 million walkers. Okay, so you can try the other ones. You're essentially asking the same thing. One thing that this one didn't talk about was interpreting the slope and what that slope and y-intercept mean. So the y-intercept, remember, was that we started with 7.6 million walkers, and then the slope is the change in the number of walkers per year.